Hey everybody, it's Miss Berry. In this video, we're going to go over section 2.4, which is called Slope in Forms of Linear Equations. So I'm going to go ahead and flip my screen around. Please excuse my voice today. I have a cold. Alright, so slope and forms of linear equations. So in this section, I'm going to give you the formula for the slope of a line. I'm going to talk a little bit about the slope. And then we'll look at two different ways that you can express lines. Now, we've already talked about standard form. So forms of linear equations, we've already talked about standard form, which was ax plus by equals c. And we'll also talk about excuse me, SlopeIntercept Form and Pointslope Form. All right, so first of all, this is SlopeIntercept Form. This is the formula or the equation for SlopeIntercept Form. SlopeIntercept Form is expressed as y equals mx plus b. X and y are your variables. These variables could be replaced with anything. X and y are the most common though. And here, m is the slope and b is the y-intercept. All right, so that's why it's called SlopeIntercept Form, because it's very easy to identify the slope and the y-intercept whenever your equation is in this form. All right, so we talked about the y-intercept in the last section, but the y-intercept is the point where the line crosses the y-axis. So it's the spot where the line crosses the y-axis when you graph the line. The slope is something that we haven't talked about yet, but I'm sure you've heard of the slope before. The first way that we learn slope is as rise over run. You probably remember learning about slope equals rise over run. Whoa, that R looked terrible. Let me try that again. Rise over run. So you probably remember learning slope as rise over run. The more, or like a fancier way of saying this would be that the rise is the change in the y and the run is the change in the x. So the rise is how much your y value is changing. That's what we have here, y2 minus y1. Your run is how much your x value is changing, which is what we have down here, x2 minus x1. And then I just noted over here that x1, y1, and x2, y2 are points that are on the line. All right, so slope is always represented by a lowercase m. So it's the change in y over the change in x, or y2 minus y1 over x2 minus x1. It's important that you write these in the correct order. The subscripts should match up. So it should be y2 goes first here, x2 goes first here, and then y1 goes second, x1 goes second. And just notice that we're subtracting in the top and the bottom. All right, so make sure you write this formula down. Very important. Let me use a highlighter instead. All right, so very important formula. Definitely something that you would want to put on your index card. The slope formula. If you don't, you may already have it memorized if you have taken algebra recently. All right, so let's look at an example using the slope formula. All right, so number 1 says, find the slope of the line that passes through the following points. Simplify your answer. Excuse me. All right, find the slope of the line that passes through the point. Simplify your answer. You may need to pause the video to give yourself a second to write this down. I'm going to start by labeling my points x1, y1, and x2, y2. Now, you could have labeled them. You could have called this first one x2, y2, the second one x1, y1. It does not matter. You'll get the same answer either way. But I just like to label them in order. Like this was the first point, so I called it x1, y1. This was the second point, so I called it x2, y2. All right, so let's write down the slope formula. M equals y2 minus y1 over x2 minus x1. Go ahead and plug in your numbers. Y2 minus y1, that's -1 minus 5. And then x2 minus x1, that's 2. Oh my goodness, I plugged in the wrong number, didn't I? Let's back it up. Y'all see what I did? All right, so we were supposed to be doing y2 minus y1. So that's -1 minus 11. That was my bad. All right, now x2 minus x1. Let's go to the denominator. x2 minus x1. 2 minus 5. All right, that was a good catch. Otherwise, that would have messed up our answer. All right, so -1 minus 11, that's -12. 2 minus 5 is -3. -12 divided, we're simplifying now. -12 divided by -3 would be +4. So the slope is 4. Right, so our slope here is 4. Here we have a positive slope. And when you have a positive slope, that means your line is going to increase. It's going to rise up from left to right. If you have a negative slope, your line goes down. It falls from left to right. But a positive slope rises from left to right. All right, let's look at another example. All right, so we have another example here. Very similar question here. But instead of giving us 2 points on the line, this time we're just given an equation that's in standard form. It says, find the slope of the line determined by the following equation. Simplify your answer. The easiest way, in my opinion, to find the slope of an equation is to put that equation in SlopeIntercept form. This is just a fancy way of saying get y by itself. All right, so get y by itself. Remember, slope-intercept form was y equals mx plus b. So we want y to be by itself. So let's get to work on our line, or on our equation. -5x minus 7y equals 21. All right, so I'm trying to get y by itself. So first thing I need to take care of is I'm just going to go ahead and add 5x to both sides. Since my slope-intercept form has the x in the front, I'm going to go ahead and just write it in the front. I don't know why I wrote 51 there. A little bit out of it today since I've been sick. All right, our 5x's cancel on the left. We're left with -7y equals, again, like I said, I'm going to put the 5x in the front, 5x plus 21. I'm only putting the 5x in the front because that's how it appears over here in my slope-intercept form. I'm almost done. Excuse me. The last thing I need to do is to get y by itself is that I just need to divide everything by -7. Now, typically you would just put -7. You would put like a large, a long division bar there and just divide everything by -7. But since we're trying to identify the slope, I find it easier just to do it piece by piece. All right, so we're dividing each piece by -7. Cancels out on the left. That's what we wanted. We're left with y equals 5 divided by negative 7, that's negative 5 over 7. X plus, whoops, not plus, right? Because I don't know why I'd erased that whole thing. 21 divided by negative 7 would be negative 3. Okay. Perfect. Now we've got it in slope-intercept form. Now to identify the slope, we just need to look at the number that's in front of x, the coefficient on x. So our coefficient on x here is negative 5 over 7. So that's our slope. All right, so our slope is negative 5 over 7. And again, we talked about this in class, but you can put the negative, you can put it on the outside over here, you can kind of put it to the side, you can put it up here with the 5, you can put it down here with the 7. It does not matter where the negative is, it's still going to be the number negative 5 over 7. Those are all the same number. All right, so there's our slope, negative 5 over 7. Again, this is a negative slope, so we know that the line would fall from left to right. So the slope gives us an idea of what our line would look like. Additionally, it also tells us that it also indicates the steepness of the line. The larger the slope is, the more steep it's going to be. It's going to get closer and closer to becoming a straight line. The closer to a vertical up and down line. And the closer to 0 that the line is, that the slope is, the line is going to get flatter and flatter, closer and closer to a horizontal line. All right, so let's look at our next page. Before I go on and do my next example, I need to talk a little bit about our special lines. We talked about these in the last section, and we already know that if we're talking about horizontal lines, that's in the form y equals a number. Vertical lines are of the form x equals a number. But what I want to talk about today is the slope of these special lines. All right, so horizontal lines have a slope of 0. The way that I remember this is that horizontal has a z in it, and it has a slope of 0. Vertical lines have an undefined slope, so we would just say slope is undefined. So horizontal lines have a slope of 0. Vertical lines have an undefined slope. This is pretty easy to explain if you think about the slope in rise over run form. You may not care about why the slope is what it is for horizontal and vertical lines, but if you do, you can watch this next part. If not, you can just skip over it. So the slope is 0 for horizontal lines because it's not rising at all. If it's a horizontal line, it's just flat. There's no rise. So the rise is 0. So it's 0 divided by whatever the run is. 0 divided by any number would be 0. And similarly for vertical lines, the slope is undefined because while the line is rising, it has no run. So the vertical line has no change in the x value. So that means that the denominator is 0. And we know that we're not allowed to divide by 0. That's undefined. So that's why the slope there is undefined, because you're dividing by 0, because there's no run. There's no change in the x values. All right, so now that we've talked, this is something that you would probably want to write on your index card. So we'll just say, oops. I don't know what's happening there. Let's just do like that. So this is good info for your note card for the test. All right, so you definitely are going to want to know what the slope of a horizontal line is and what the slope of a vertical line is. All right, so let's look at an example. All right, so it says find the slope of the line determined by the following equation. Simplify your answer. So we have 8y equals 7. First thing we need to do, you can probably already tell what type of line this is, but we could get y by itself by dividing both sides by 8. The 8's cancel on the left, and you're left with y equals 7 over 8. We can tell just by looking at this that this is a horizontal line. We can tell because horizontal lines are always of the form y equals a number. And we just talked about what the slope of a horizontal line is. We said that the slope of a horizontal line is 0. So super easy there. Just have to remember those two facts, that the slope of a horizontal line is 0, the slope of a vertical line is undefined. All right, let's look at another example. I'm sorry, we're actually going to look at point-slope form next. All right, so this is point-slope form. We already talked about standard form. We talked about slope-intercept form. This is point-slope form. Point-slope form is very useful. This is something that you want to have written down on your index card. So point-slope form is y minus y1 equals m times x minus x1. Point-slope form is actually derived from the slope formula. So you could just divide both sides by x minus x1, and it gives you back the slope formula, which is kind of cool. Here, of course, m represents the slope, and x1, y1 is just a point on the line. And again, we talked about how slope-intercept form was called slope-intercept form because you can easily identify the slope in the y-intercept. Point-slope form is called this because you're going to use this form if you know a point on the line and the slope of the line. So all of these problems that you do with point-slope form, you're going to know a point on the line and the slope. This is one of my favorite types of problems, so definitely expect to see some kind of example where you have to use point-slope form on the test. All right, so I picked this question because I like the way it was worded. It says, find the equation of the line in slope-intercept form that passes through the following point with the given slope. Simplify your answer. So I thought this was a good problem because it's almost like they're trying to trick you by saying slope-intercept form, and they have it bolded up here. Because when you look at what we're given a point in the slope, so that indicates that we should use point-slope form. Now, what this part up here means, so what this part means is just, all that means is just get y by itself when you type in the answer. So that's all that means. All this is telling us is to get y by itself when you type in the answer. All right, so we have a point, 0, -10, and then we have the slope, which is -2. I tried to pick a couple of variations for us to do of this problem. Ones where we had a positive slope, ones where we had a negative slope, and examples where we had a fraction for a slope, and different types of points here. So let's go ahead and write slope-intercept form. Slope-intercept form looks like this. Excuse me, not slope-intercept form. I meant to say let's go ahead and write point-slope form. So point-slope form is y minus y1 equals m times x minus x1. So we need to know a point, x1, y1. We're given that point, x1, y1, and we're given the slope. Now all we need to do is plug that in. Y, nothing's going in for y. Okay, so you just rewrite y. Y minus y1 is -10. M is -2. Parentheses. X minus x1 is 0. All right, hard part's done. Last thing we need to do is just get y by itself. All right, so negative and a negative, double negative, we know that makes a positive. Let's make that into a positive. All right, so just y plus 10 equals, let's go ahead and multiply through by -2 here. Well, actually, we don't really have to multiply anything in here, right? Because x minus 0 is just going to be x. So that's just -2x. So nothing to distribute there because that 0 is just going to knock it out. X minus 0 is just x. All right, almost done. We just got to get y by itself, so go ahead and subtract 10 from both sides. Put it at the very end. So we have y equals -2x minus 10. We just cancel these out right here. And we're done. That was it. Just find the equation in slope-intercept form. Okay. All right, let's look at another type of example, another similar question to this, just with different numbers. All right, so I picked this one again. It's the same exact question, just this time we have a fraction for the slope instead of a whole number. Or in the last one, we had a negative whole number. All right, so same idea here. We're going to write down the equation for point-slope form because we're given the point and the slope. So go ahead and write point-slope form. Label your point x1, y1. The slope is -3/2 is m. Go ahead and plug in your numbers. Y minus, y1 is again -10. That was just a coincidence. M is -3/2. And we have x minus x1 was 9. All right, so let's go ahead and simplify some of this. We know that double negative again becomes a positive. So we have y plus 10. Now we're going to have to distribute on the right-hand side, multiply through by -3/2. All right, so we have -3/2 times x. Negative times a negative is a positive. And then 3/2 times 9, that's going to give you 27/2. You can do that in your calculator though, if you wanted to. I just did 3 times 9 is 27. Denominator stays the same. We're almost done now. Remember, last thing we got to do is just get y by itself because they want the answer to be in slope-intercept form. Right, so go ahead and subtract 10 from both sides. Let's get our calculator out and subtract that so we don't have to try to get common denominators in our head. All right, so I'm going to back out here and then pull up my document camera. Get it adjusted properly, and then I can focus it. There we go. All right, so we have 27/2 minus 10. 27/2 minus 10. Notice I didn't put a parenthesis anywhere. Your calculator knows that this is a fraction. You don't need to put parentheses around it. So 27/2 minus 10. It's going to give it to me in a decimal. Your homework may accept a decimal as an answer, but just in case they want it as a fraction, I'll show you how to convert that to a fraction. Just press this math button down here. It's at the, underneath that alpha button. So hit math. See the first option there has a little arrow and it says frac. That means convert to a fraction. So just hit enter. So it says take the answer from the previous line and convert it to a fraction. So that's 7/2. All right, so we have negative, let's make this full screen again, -3/2x, whoa, pressed a button on my pen, sorry, plus 7/2. And that's it. You don't have to do anything else with this. They just wanted you to write it in slope-intercept form. So basically take the information that you're given, the point and the slope, come up with the equation. All right, last problem. This is sort of like the culmination of everything you've learned in this section. It says find the equation of the line in slope-intercept form. That means just write your answer with y by itself. That passes through the following points. Simplify your answer. So they give us these 2 points, -5, 11 and -3, 7. We can't just jump straight to point slope form because although we do know a point on the line, we do not know the slope yet. So that's going to be our first step, is to find the slope. And then step 2 is going to be use point slope form to find the equation. All right, so step 1, find the slope. Step 2, use point slope form to find the equation. All right, let's write the slope formula. M equals y2 minus y1 over x2 minus x1. All right, go ahead and label your points, x1, y1, x2, y2, and then plug your numbers in. All right, so we have 7 minus 11, y2 minus y1, 7 minus 11. Being super careful here to pick the correct numbers. x2 minus x1, so that's -3 minus -5. Okay. Let me show you how you could do this in your calculator without having to do any of this in your head, since we already have our calculator pulled up here. All right, clear everything out. It's nice to start with a clear screen. That way you just make sure you don't have anything left over that just creeps into your, into the information that you're typing. All right, so we have 7 minus 11 over -3 minus a -5. All right, so put the numerator in parentheses. 7 minus 11. Anytime you're doing some kind of operation in the numerator or in the denominator, you always want to make sure and put either, the numerator or denominator, whatever you're doing the operation in, make sure you put that in parentheses. So your calculator knows, okay, do this first and then divide it by whatever. So 7 minus 11 in the parentheses, divided by, then in another set of parentheses, put the denominator. So -3. We know a double negative becomes a positive, so we can go ahead and switch that to a +5. Close parentheses. And there's our slope, -2. All right, so that equals -2. So now we know M is -2. We know a point on the line. We can go ahead and use point slope form. We know a point, we know the slope, to find the equation. I think I missed a word here. Use point slope form to find the equation. That was my bad. All right, so when you're picking which point that you want to use, it does not matter if you use x1, y1 or x2, y2. I'm just going to go ahead and use this first point. Like I said, if you use -3, 7, you're going to come out with the same answer. So no worries. You just pick one or the other point. All right, so here's our point, -5, 11, and our slope is -2. It's going to be our x1 and our y1. So let's write the formula for point slope form. Y minus y1 equals m times x minus x1. Go ahead and plug in your numbers. So y minus y1, so y minus 11 equals m was -2 times x minus x1 was -5. We know that that double negative becomes a positive. We can go ahead and fix that. Right, so nothing to simplify on the left, just rewrite that. Now go ahead and multiply through by 2. All right, so multiplying through by -2. Okay, so we get -2 times x is -2x. -2 times 5 is -10. We're almost done. We just need to get y by itself, so go ahead and add 11 to both sides. Move that 11 over. We get y equals -2x. -10 plus 11, that would be +1. And you're done. Okay. So this, again, sort of combines everything that we've learned in this section. We have to find the slope. We have to use Pointslope Form to find the equation. And then at the very end, we have to make sure it's in SlopeIntercept Form. So it really combines everything that we've learned in this section. So this is a good test question since it combines everything into one. So that's a good test question. If you have any questions about this section, or if you're struggling with anything in the homework, please let me know. Otherwise, I'll see you guys in class. Have a good day.